Nuclear weapons are the most destructive creation of humanity. But the main thing is that it is dangerous, not only on land, but also underwater, and even in space. The consequences of explosions in each environment are different. If everything is more or less clear with land and water, space still remains a mystery. What do you think will happen if nuclear weapons are launched there? And not one, not 10 charges, but all at once. In today's video, I decided to conduct exactly such an experiment. Actually, I was not the first to come up with this idea. Similar experiments have already been conducted several times. One of them was the Argos operation, a series of secret nuclear weapon tests by the USA over the Atlantic Ocean. Explosions were carried out at different altitudes in August and September of 1958. And who could have thought that it would be possible to launch projectiles so far? The first two warheads managed to rise to 170 kilometers and 310 kilometers above the ground. The third exploded at an altitude of 794 kilometers, but the launched projectiles were not powerful enough to cause any damage. All three nuclear warheads W-25 had the same explosive power, each totaling about 1.5 kilotons. How much more interesting and grandiose was the Starfish Prime operation? Within its framework, a series of projectiles were also launched to a great height. The goal was to study how a nuclear explosion would behave in outer space, and it seems not only this was successfully clarified. Then people learned about the consequences. The first test was conducted on June 20th, 1962, and just a minute after the launch, everything went off plan. A malfunction in the booster engine of the Thor rocket led to its disintegration. For safety reasons, the rocket had to be destroyed along with the warhead at a huge altitude. At that time, it had already reached an altitude of about 10 kilometers. Fragments of the rocket and nuclear device fell on Johnston et al. Where was the launch carried out from? And as you understand, the consequences were serious. The accident caused radiation contamination of the area. The second attempt to launch was scheduled for July 9, 1962. The test was conducted over the same atoll in the Pacific Ocean. The new Thor rocket and a new nuclear warhead set off into space again. The 1.44 megaton W-49 thermonuclear warhead was activated at an altitude of 400 kilometers. This, among other things, is very high. For comparison, the International Space Station is located at a distance of 417 kilometers from Earth. It remains only to be glad that at the time of this nuclear explosion, it had not yet been created. But how did the ammunition behave? In space? Obviously, the explosion was completely different from what happens on Earth. Here, in the airspace, we could have seen a familiar nuclear mushroom. But at a huge height, there is practically no air. Therefore, there will be no radioactive cloud. But it is not worth thinking that nothing interesting happened. On the contrary, the special effects were even cooler than in the movies. A high-altitude nuclear explosion caused a powerful electromagnetic pulse. Short-term electromagnetic field. It is capable of disrupting electronic equipment, electrical appliances, and power lines. Yes, in Hawaii, about 1,500 kilometers from the epicenter of the explosion, 300 streetlights and countless other electronic devices malfunctioned. In this same region, for about 7 minutes, a glow similar to the northern lights could be observed. But that's not all. The projectile explosion also affected spacecraft. The same electromagnetic pulse immediately disabled 3 satellites. Charged particles were also formed as a result of the explosion. Due to their high concentration, solar panels and electronics in 7 satellites were affected. Overall, the explosion caused significant damage. It disabled a third of the spacecraft that were in low orbits at the time of the explosion. All these tests taught humans a very important lesson. nuclear weapons are not to be trifled with. Similar experiments can lead to destructive consequences. And what I have told you is only a small part of what is possible. That is why a special treaty was signed back in 1963. It prohibits testing nuclear weapons on Earth, underwater, and in space. But let's imagine for a few minutes that this treaty does not exist. What would happen if all nuclear warheads suddenly ended up in space? The world's nuclear arsenal is being improved every year. Countries are creating more powerful and destructive weapons. However, according to official data, its quantity has been decreasing until recently. At the beginning of 2019, there were only 13,865 warheads in the world. In 2018, 14,465. This entire arsenal belongs to only 9 countries: the United States, Russia, Great Britain, France, China, India, Pakistan, North Korea, and Israel. The USA and Russia possess 90% of this quantity. Everything else was divided among the rest of the countries. But no one can know how many nuclear weapons are actually in possession. Part remains hidden, part undisclosed. So let's take the approximate number of 15,000. That's exactly how many devices I plan to launch into space. The power of modern nuclear warheads from strategic carriers ranges from 150 to 550 kilotons. But I will not consider the power of each. Let's take the average value. Let's assume that each nuclear warhead launched into space will create an explosion power equal to the explosion of 350 kilotons of TNT. Is it worth waiting for a grand fireworks display? Undoubtedly. However, we will not only get a light show, but also the most powerful electromagnetic pulse. Let's take a few seconds to remember the Starfish Prime operation. The consequences of the explosion of a warhead with a power of 1.4 megatons disabled a third of the satellites and a lot of electronics. Debris from the malfunctioning rocket and warhead led to contamination of the area. Through simple calculations, I found out the consequences of the explosion of 15,000 warheads. It turned out quite sad. Such a number of warheads will create an explosion with a power of 5 into 250 megatons. This is 3,750 times more powerful than the warhead launched from Johnston Atoll. Can you imagine the consequences already? Let's assume the nuclear devices won't fly too high. An explosion at an altitude of 400 kilometers above the Earth will be enough to disable all satellites. And there are already over 2,000 of them now. And you do remember that the ISS is located at this altitude, so its crew is unlikely to survive. Firstly, all onboard electronics will stop working. Secondly, in the vacuum of space, nothing hinders the spread of gamma radiation itself. But what about the inhabitants of Earth? With an explosive power of 1.4 megatons, electronics were affected within a radius of 1,500 kilometers from the epicenter of the explosion. With a projectile detonation of 5 to 250 megatons, disruptions can be expected within a radius of 5,625,000 kilometers. For comparison, the radius of our planet is 6,371 kilometers. The affected area is 883 times larger. In simpler terms, all electronic devices on Earth will suffer from such a massive experiment. But the consequences are not the worst that could happen. There is always a possibility of an accident, which means the fall of radioactive debris and the contamination of the Earth. And you probably think, what would happen if we launch warheads a little further into space? Currently, almost all carrier rockets are intended for flights into low Earth orbit. The exception? Perhaps only the Saturn V, which was involved in landing on the Moon. But launching such a spacecraft costs a lot of money, and hardly anyone can make the necessary quantity of rockets. Therefore, bombarding celestial bodies is a completely different story. I will leave it for another video. If you liked the video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't already. Click on the bell to receive timely notifications about the release of new interesting videos that are waiting for you ahead.